Welcome to the University of Salford's Energy House Test Facility. It's home to the Applied Buildings and Energy Research Group, a multidisciplinary team dedicated to investigating the issues of energy use in buildings. These kinds of problems can range from issues around materials, systems, controls, as well as the way people use energy in their homes. It's important because 30% of all the energy used in the UK is used in our homes, and 45% is used in all buildings. The team here are dedicated to gathering the evidence to help us understand how we can reduce energy use in the buildings in the UK. Through these doors is the Salford Energy House. We built it in 2011 to better understand the problems of energy use in our homes. There are two important elements that help us understand the problem in more detail than we might be able to do traditionally. The first is we can control the weather, so that tests that might take up to 2 years in the field can be done in a few short weeks. The second issue is the fact that we have a whole house. We know that when we test individual products in the lab, they don't always perform in the same way in the field. By testing as a whole system or a whole house, we can understand how systems work together and get a better understanding of how things will work in practice. Another problem with domestic energy use is that the older housing stock accounts for a large proportion of the buildings we have. Many of the buildings that are already standing will still be here in 2050. This means we need not only to think about new energy efficient buildings, but also what we have now. So there's a need for retrofit, making existing buildings more energy efficient. And this is not a simple problem to solve. We've been able to address this problem by testing a wide variety of products in the home, from simple energy saving devices such as the Rad Fan or Combi Save, which can be used in existing homes, to whole house retrofits. The house itself is a pre-1919 Victorian terrace, similar to around 20% of the UK housing stock. It's made from locally reclaimed materials, it has lath and plaster ceilings and a suspended timber floor. The house is a solid wall property and sometimes known as hard to treat, which means it can be a real challenge to retrofit. There are two important parts to this unique facility. First is the house, and the second is this chamber that allows us to control the weather. So we can control temperature, rain, wind and solar. And all of those issues we can control to quite a tight degree. For example, temperature can go down to -12 or up to +30, and we can hold that within half a degree. This level of control allows us to repeat experiments. It means we can make changes to the house and run the same weather patterns. When we compare that to trying to study things in the field, the variability of the rain, the wind, the solar, all impacts the performance of the building. And when we can't control those factors, it makes it very, very difficult to conduct experiments, which is why they take such a long time. With the Energy House, this problem is removed. We can take the noise out of the data, which means we can test far more quickly than we'd be able to test in the field. When we come inside the house, we can see that it's furnished like any other residential property. It depends on the nature of the experiments we do, so we may have furniture in, or we may strip the property right back. But right now, it's in its normal state, so we can see sofas, appliances, just like any other property. Because no one lives here, we can do things that we wouldn't be able to do in real homes. We can change the doors, the windows, the heating system, or even do whole house retrofits, something that would be very difficult when working around occupants. There are over 100 environmental sensors throughout the house, measuring temperature and relative humidity. This means we can have a really detailed understanding of environmental conditions within each of the rooms. At the corner of each room, at 3 different levels, and at the geometric centre of the room, we measure temperature and relative humidity. This helps us understand how an occupant in the room might experience comfort. It's important to gather this data because temperature can vary by quite a large degree from one corner of the room to another. To understand the energy efficiency of the property, we need to measure the overall gas and electricity consumption. We can see here we're measuring at the appliance level, so each socket is measured, understanding what this microwave would use. We have 2 types of sockets in the property, one to measure appliances and other red ones where we plug in our testing equipment. This means that we don't take into account the energy used by our testing equipment into the whole consumption of the house. Currently, we have a gas combi boiler, common to most UK homes. But if needs be, we could replace that with a different boiler or an entirely different system, such as electrical radiators or an air source heat pump. It allows us to compare and contrast how different heating systems perform. To understand the efficiency of a heating system, we need to monitor the system closely. For a system like this, we would measure the flow and return on the boiler, the surface temperatures of the radiators, and heat meters on the radiators. This gives us a very detailed picture of the overall efficiency of the system. As well as measuring energy use and environmental conditions, we can also monitor other things. For example, here we can monitor water, and that's an increasingly important issue for the built environment. In addition, we could also measure things like CO2 or air quality, or we could measure the U values to check the thermal conductivity of the walls. Although the property is unoccupied, we can replicate many of the effects an occupant might have that affects the energy performance of the building. For example, we have actuators that can do window opening, door opening, fridge opening, all of which affect the performance of the property. In addition, we can turn the appliances on and off as we need. We can repeat these patterns so the pattern of occupancy is the same each time for each experiment. Here we are in the conditioning void, which we use to replicate the effects of a neighbouring property. We also use it to house some of the equipment, such as the tank for the rainwater and some of the control systems that influence the weather in the chamber. All of the data we collect goes back to the lab, where it is analysed using an on-call system. Obviously, this is a huge amount of data, with up to 2 gigabytes of data being collected each week. Over the last 4 years, one of the things we've learnt about the Energy House is the ability it gives us to test other methods of building performance evaluation. Over this time, we've tested things like whole house heating methods, such as co-heating, different ways of measuring U values, and different types of monitoring equipment, all of which can be compared and validated against the scientifically calibrated equipment within the house. The Salford Energy House is a world's first, and it remains the only whole house within an environmental chamber in the world. It's an important role to play in helping us solve the problems of energy efficiency in our homes. We've been working with a variety of research partners from universities and industry partners to try and find out what works for energy efficiency. The University of Salford's committed to making sure that our research makes an impact, and we're dealing with a problem that works on not only a global scale, but also affects us all individually and personally. The Salford Energy House has an important role to play to help us find answers to these problems.